Welcome back, tech leads, developers, and builders, to today's explainer. So, if you've ever built a super quick, mind-blowing AI prototype in just a single Python file, only to watch it completely fall apart the second you tried to scale it for real users, well, you are in exactly the right place. Today, we are going completely under the hood to demystify what a real, scalable, production-ready AI application actually looks like. We're moving way past those basic toy examples and unpacking a true, battle-tested, 9-layer production architecture.
So let's just dive right in, shall we? There's a quote from our source material that I think perfectly captures the absolute danger of treating AI apps like simple little scripts. Building an AI feature? That's easy. But building an AI system? That is incredibly hard. When developers rush to market, they almost always skip the critical structural layers that actually ensure reliability, safety, and performance. They ship blind. So today, we are going to open our eyes and look at the actual blueprint required to keep an AI application from completely collapsing in production.
Here's our mental roadmap for the breakdown. We're going to start by looking beyond toy AI, then unpack the core intelligence engine, lock down ironclad security and prompts, tackle the all-important evaluation and observability, and wrap it all up with the modern developer experience.
When you map out the complete blueprint, you get this majestic 9-layer production directory tree. It is a massive structure, and yeah, honestly, it might look a little intimidating at first glance, but this complexity is absolutely necessary. Every single piece, from your FastAPI entry point at the very top, scaling all the way down through the specialized components, services, security guards, and right into the agent context at the bottom, it all serves a specific, vital purpose in a live environment. We're going to systematically unpack this tree so it all makes perfect sense.
All right, Layer 1. Beyond toy AI applications, the 9-layer reality.
When you compare the high-level philosophical framework with its literal code-based implementation, it brilliantly illustrates the difference between an amateur approach and a true production setup. A toy application is basically a Frankenstein monster that jams everything into one main.py file. But a production architecture, it strictly separates concerns. The FastAPI entry point, your configurations, and your schemas are totally isolated at the top level. Custom retrievers like hybrid search live in their own dedicated components folder. It's a highly deliberate separation that makes the app actually maintainable over time.
Moving to Section 2, the Core Intelligence Engine, featuring our services and agents.
Let's peek inside that services directory. In a real-world app, your core business logic is never, and I mean never, jammed into your main routing file. Instead, it's split into specialized services. You have a dedicated file for your RAG pipeline. You've got another one specifically for semantic caching, which is huge for saving on API costs and speeding up repeat queries. You have totally isolated files for managing conversation memory, rewriting queries for better retrieval, and intelligently routing queries to the right destination.
Our source material really hits the nail on the head with a punchy observation about this specific layer. Not one file, 5. Honestly, this is the ultimate litmus test for whether an application is built for reality. Modularity isn't just a nice-to-have, it's a strict requirement for scaling. When a bug pops up in how a query is routed, you do not want to be sifting through 1,000 lines of RAG pipeline code to find it. You just go straight to query_router.py.
Now, what's really fascinating is how this intelligence layer actually operates. Inside the agents directory, we find the absolute brains of the operation: a document grader, a query decomposer, an adaptive router, and pluggable tools for things like web or code searches. By breaking these tasks down into highly specific Python files, the system essentially becomes self-correcting by design. If a retrieval fails, the adaptive router can just kick it back to the query decomposer. The document grader can dynamically evaluate if the source context is actually relevant. It's literally a team of agents working together rather than a single monolithic script just crossing its fingers and hoping for the best.
All right, Section 3, ironclad security and prompts, because we absolutely have to control that output.
Stepping into the prompts directory, the contrast between amateur and production AI is just night and day. Amateurs rely on hard-coded prompts buried deep within execution scripts, meaning if you want to tweak a basic system message, you literally have to modify the core application code. Production AI, on the other hand, isolates those prompts into templates.py and a registry.py. Prompts are treated as versioned, type-specific, hot-swappable assets. The golden rule here is incredibly simple. Prompts are never, ever hard-coded.
And see how this philosophy flows right into the security layer itself? In a real setup, you don't just have a single flimsy safety check. You have a clear three-step flow: an input guard, a content filter, and an output filter. Real applications use 3 guard layers, not 1. They sanitize the user's initial input to shut down prompt injection, they meticulously filter the retrieved content for sensitive data, and they scrutinize the LLM's final output before it ever reaches the user's screen.
Section 4. Crucial evaluation and observability. The whole don't ship blind philosophy in action. Inside the evaluation directory, the absolute holy grail is your golden_dataset.json. If you're not familiar, a golden dataset is a definitive, high-quality test set of inputs and expected ideal outputs. Running this alongside offline evaluation scripts and online monitors allows developers to objectively track historical performance. Think back to our opening hook. Most people skip this entire layer and ship blind. Without a golden dataset and automated evals, every single time you update a prompt or change a model, you're literally just guessing whether the app got better or worse.
Because let's face it, you cannot evaluate what you cannot see. The observability directory provides literal X-ray vision into the live application. Using dedicated tracer, feedback, and cost tracker modules, developers can capture per-stage tracing of exactly how a prompt traversed the entire system. They can link user feedback directly to those specific traces to see exactly where an answer went off the rails. And crucially, they can break down the exact financial cost per query. This is how you run a predictable software business, not a chaotic science experiment.
And finally, Section 5. The modern developer experience, where AI is literally your teammate. Down at the very bottom of the directory tree, there is this hidden .claude folder containing rules for code style, testing, and project memory. The big takeaway here is this. Modern production architectures actively assume that AI is part of the development team. By placing an agent context folder right there in the root directory, you are creating a self-documenting workflow that's specifically designed for your AI coding assistants. This is a total game changer for how we write software. Because of this dedicated directory, your AI coding assistant knows the architecture, the code style, and the project rules before it even touches a single file. You don't have to constantly remind your AI about how your project is structured or what testing framework you're using. The repository itself enforces the alignment. It just makes the entire development lifecycle faster, cleaner, and incredibly consistent. Okay, let's zoom back out for a second and look at the forest, not just the trees. We have totally demystified this majestic 9-layer production architecture, from the FastAPI entry point all the way down to the highly modular services and those brilliant self-correcting agents. We've got strictly versioned prompts, triple-layered security, and rock-solid evaluation datasets. Every single folder is a load-bearing pillar holding up a robust ecosystem that will not crumble under real-world pressure.
Which leaves us with one incredibly important question to ask yourself. Sure, your AI app works flawlessly on your laptop, but does it actually have the 9 layers to survive production? Take a really hard look at your own repositories today. Are you jamming everything into one massive file? Are you shipping blind without any evaluation? Well, it might just be time to start building for reality. Thanks so much for joining me on this explainer, and happy building!